Okay, in step 2, we have to configure high availability active mode on both ASA1 and ASA2. Let's go to the topology. Okay, if you notice here, we have 4 ASs here in total. Now, before I talk about the ASA active failover, let me talk about the requirements. Both for the active and active standby, all the ASA devices has to be identical. The hardware version has to be the same. Of course, the iOS version has to be the same. Most importantly, the interface allocation has to be the same. That means whatever interface we are using for the outside interface in the primary unit, it has to be the same interfaces as well in the secondary unit for the outside interface as well. Same for the inside interface. Whatever we are using for the inside interface in the primary unit, it has to be the same in the secondary unit as well. If you notice, we have two fabrics. And in the primary unit, I'm using ETH2 and ETH1 for outside. This is the secondary unit. If you notice, we have ETH1 and ETH2. I have ETH5 and ETH6 for the inside. In the secondary unit, I have also ETH5 and ETH6. Now this two interface is used for failover configuration. So ETH4 is the failover link. In production network, they used a high speed connectivity here because both ASs is going to use this interface for data synchronization, and the other link, which is Ethernet 3 in both ASs, is used for the stateful configuration, for the stateful failover configuration. Failover can be configured in both stateless or a stateful method. So the difference is in a stateful method, we have the source MAC, the destination MAC, the source IP, the destination IP, and a lot of other information. If you already notice, we have two failover configuration here. ASA1 and ASA2 is for failover 1, and ASA3 and ASA4 is for failover 2. There is no connection between these two groups. They are working individually. Let's talk very briefly about the security context. The security context is nothing but dividing a physical firewall into multiple virtual firewalls. Those virtual firewalls are known as the security context, and you can name it whatever you want. In my topology, I name them as context A and context B. That means in ASA1, I have two virtual firewalls as well, and they work independently. They have different class map, they have different policy, they have different storage. So simply within one physical firewall, you have multiple virtual firewalls. In failover 1, I have two security context, context A and context B. In context A, both the firewall is using Ethernet 1 and Ethernet 5 for forwarding the traffic. ETH1 is for the outside and ETH5 is for the inside. In context B, that means in virtual firewall B, both firewall is using ETH2 for outside and ETH6 is for inside. AS1, the primary unit, is the primary for the context A. The secondary unit is the primary for the context B. You can do vice versa, but I made it simple. The same principle here as well. This is failover fabric 2. We have context C and context D. Again, context C means that's a virtual firewall. Inside ASA3, I have context C and context D. They are virtual firewalls. Simple. And in context C, it is using ETH1 and ETH5 for outside and inside. And in context D, it is using ETH2 for the outside and ETH6 for the inside. And for your better understanding, if you zoom in or if you take a quick peek, you will notice I have label in every interfaces that which context it is dedicated for. Like if you notice here, outside A, ETH1, that means this is context A. Outside B means context B. Same here as well. If you notice in every interfaces, I have named them. ETH1 is for context C, ETH2 is for context D, and whatever will be in the primary unit, the secondary unit will have the similar interface allocation. That is the requirement for the active failover. And that will be all for this brief discussion. I'm not going to dig detail about the active failover. You can do some YouTube research if you want to learn in detail about the active failover. The most important thing to remember for this lab, for failover fabric 1, any configuration in Ethernet 1 and Ethernet 5, we have to deploy them inside the context A in the primary unit ASA1. And anything for outside B, that means Ethernet 2 and Ethernet 6, we have to deploy them inside the context B in the secondary unit ASA2. And very identical principle here as well. Anything for ETH1 and ETH5, we have to deploy inside the context C in the primary unit ASA3. And lastly, anything for Ethernet 2 and Ethernet 6, we have to deploy them inside the context D in the secondary unit ASA4. That's all. With that being said, let's go to the configuration mode. Okay, now let's go to the ASA1 and let's go to our script. We also have a picture here to give us a better understanding. We're simply going to copy and paste. This configuration, like creating the security context, is only required in the primary unit, which is ASA1, and the ASA2, the secondary unit, will synchronize all the configuration via this failover interfaces. So we are going to only configure the ASA device 1. Okay, so the first command is context ctxa. Ctxa is just a name, and then we have to create a virtual storage, and that is config-url flash clone/ctx.cfz. cfz is the extension. And then we have to allocate the interface. If you see, as I mentioned, eth1 and eth5 will be for context A. If you see here, allocate interface E5 inside, that means for the security context A, Ethernet 5 is dedicated for the inside interface, and I just named them inside A. That's all. You can name whatever you want, but I have tried to make it simple. And then allocate interface E1 for outside A. That means again for security context A, E1 will be the outside interface. And the eth2 and eth6 has nothing to do with our security context A. We'll leave them alone. And then allocate interface E7 management. We are also using a management interface. If you see, we have management network here. So we are allocating this inside the context A. If you want, you can do this allocation in the context B. It's up to you. We'll exit out and then create the context B. Same command. By typing ctxb, the context will be created, and then we'll create the virtual storage, and then we'll allocate the interface as well. Allocate interface E6 inside B. So this time the Ethernet 6 is dedicated for context B here for the inside interface in both ASs, and then allocate interface E2 for outside B. In both ASs, the Ethernet 2 interface is dedicated for the outside interface, and then we can verify that show run context, and if we want to remove, we can say no context, and then we have to call the context name. Okay, let's do that. First we'll change the host name, and the second command, we have to run all these firewalls in the multiple mode. By default the firewall runs in single mode, but we have to change them in multiple mode, and then the firewall will reboot. If we just type show mode, you see this is single. We don't need that. We need to run all the firewalls in multi-mode. So we'll say it's rebooting. Let's do that for all the firewalls. All of them are rebooting with multi-mode. Okay, this is ASA1. Okay, now we'll copy everything. Now we'll create the context B. Now if we notice here, this is our security context. Inside the context A, we have Ethernet 1 and Ethernet 5 and management 7, and inside the context B, we have Ethernet 2 and Ethernet 6 for outside and inside. Now we are going to configure the failover in ASA1. This will be the primary unit, but we need to configure the same configuration in the ASA2 as well, here as well. So the first command, failover LAN unit primary, because that is the primary unit, and then failover interface, which is eth4, and we named it failover, and then failover interface IP failover. This is the IP address. We also have to give the standby IP as well, which is 25.25.25.2 and 25.25.25.1. We are using /30 mask here. We know that in the /30 we have 4 hosts, 2 of them are usable anyway, and then we have to configure this stateful link. So failover link stateful eth3, because we are using eth3. Failover interface IP stateful. Stateful is just a name, and then here we will give 25.5 and standby will be 25.6. Let's do up to this part. Okay, for this command I need to give a little explanation why am I giving this command, because this is not a requirement for the active failover. The only reason I'm giving this, because when I'm going to configure the failover in ASA1 and ASA2, the name will be very identical. It doesn't matter what host name I give here, it will appear as the primary unit here. Sometimes it is very confusing that which ASA I'm in at the moment and what security context we are in. So with this command, prompt hostname context state priority, it will show us what is our primary unit, what is the name there, and what security context we are in. So let's skip this command. and then we'll bring the interfaces up. Okay, we are done in the primary unit. We'll do the same configuration in the ASA device too. The only difference is, instead of saying primary, we'll say secondary here. That's all. Okay. If you notice, I have not typed failover yet because there are still configuration needs to be done before I hit failover. Because the moment I type failover in both ASs, they will start to synchronize the information. But I'm not done yet. Now we are going to create the failover group. As I said before, there could be 2 maximum failover group in one physical ASA. If you notice here, failover group 1 primary preempt, and then failover group 2 secondary preempt. That means in the ASA 1, inside this ASA device, failover group 1 is the primary and failover group 2 is the secondary, and failover group 2 is going to use the security context B. Let's copy this. Okay, now paste it. We need to tell the ASA1 device that context A should join the failover group 1 and context B should join the failover group 2. We'll type it. And then finally we'll type failover in both ASs, ASA1 and ASA2. So this part, like creating the failover groups and associating the failover groups with security context, we don't need to deploy them in the secondary unit as well. We can just do it in the primary unit and the secondary unit will just synchronize them. The only thing we need to do in the secondary unit as well, the failover configuration itself, nothing else. Not the security context, not the interface allocation, not the failover group creation, and not the security context merging. Everything we'll do in the ASA1 except the failover. So now we'll say failover in both ASA. As soon as I hit failover, you will see that the name will be changed. Did you see the dot? Detected an active mate. Beginning configuration replication from mate. It has started to replicate all the configuration from the primary device. Group 1 detected, group 2 detected. Now as I said, it changed the name. Okay, now we can verify. We can say show failover. Now you see this is the state table. We talked about that earlier, and group 1 is active, group 2 is standby ready. Okay, the very important thing from now on, anything for the Ethernet 1 and Ethernet 5 will deploy them inside the context A in the primary unit in ASA 1. Similar way, anything for Ethernet 2 and Ethernet 6 will deploy them in the secondary unit inside the context B. How do we have to go to the context? We can say change to context. I can say context A. Now if you notice here, we're in the context A. If we say B, we're in the B. If we want to go to the system mode, like admin context, change to system. Now we're in the admin context. Simple. Okay, now we have to configure the interfaces inside context A and context B. We have already done the interface allocation while we are creating the security context, but we have not defined the interfaces. We know that in the ASA devices, we have to do the name if, like define our interfaces. We have to give them security levels and stuff like that. I'll go to the context A first. And if I type show interface brief, this is our interface. Inside A, management, and outside A. Inside A means ETH5. Outside A means ETH1. And management is the Ethernet 7 we have used here. Allocate interface E7 management in the context A. So we're simply going to copy and paste it. Anything we do in the active mode, we have to do the standby as well. We have to give the standby IP as well. So IP at 10.1.30.34, 255, 255, 255, 248, and the standby will be 10.1.10.35. It has to be from the same subnet mask, same block. What I'm saying is, for the inside A, the primary unit has 34 and the secondary unit has 10.35. Now we are going to configure the outside interface. And similar configuration for the management interface as well. Okay, so our context A interface configuration is done. Now we'll go to context B, and then we don't need to do the show interface IP brief because we know that inside B means ETH6 and outside B means ETH2. So let's go to ASA2. Have to go to the context first. Show interface IP brief. If you see inside the context B, every port is up. Let's go to the ASA1 and context A. Every port is up, so that's good. Now we'll deploy the OSPF interface authentication inside the context A and context B. This is our ASA device 1. I'm already in the context A, so let's copy this. Okay. And then for context B, I need to go to the ASA2, but let's copy that first. Okay. We can verify that if I say show run interface inside B. If you see, the hashing mechanism is there. We can do the same thing here as well. Show run interface inside A. If you notice, the hashing mechanism is there, so it's good. Now lastly, we'll enable the monitor interface. Well, this is not mandatory, but it is better to do. Again, we have to go inside the security context to monitor our interfaces. So I'm already in the context A, so I don't need to type this anymore. We can just say this. It's done. For ASA2, we'll copy from here. I think I can just copy this too. So let's type this. Now if I say show monitor interface, now if you notice, it says waiting and the other two interface is shut down. I don't know why it's shut down. I'll make sure it's not shut down. Now if you see here, it says monitored. It should always say monitored. We know why the management interface is not monitored, because we do not have management interface for the secondary unit as well. Other than that, everything looks okay for the ASA device 1, the primary unit. But I'm not sure what happened to the ASA device 2. Let's figure it out. Why it says shutdown. I always like challenges because it gives us more opportunity to learn. Maybe the physical interface is shut down. Let's figure it out. So I'll go to the first. Let's see what is from next. Interface is for E2 and E6. E2 and E6. Go up. Okay, let's go to RSP. It's up. The device says shut down. 15.1, 15.1, 15.19. Some problem happens when I was configuring the interfaces. So let's pause the failover. I can say no failover. I can also do the same here. Now let's retype this, and then I'll try to bring this port manually up again. And then if I say failover, okay, let's go to context B. Yep, if you see waiting, it will be up in a minute. They all are waiting. Let's wait for a minute. Now if you notice, everything is monitored. That's good. Well, same here as well. So everything looks okay. So what happened during this security context configuration, like interface configuration, somehow the ports didn't get up in the context B when I was doing in the ASA device 1. Okay, now if everything goes okay, then ASA device 1 from the context A should be able to ping core router 1 10.25. Let's ping that. I'm in the context A. You cannot ping any devices from the system admin. If you notice, I can ping that. ISP router 1. I should also be able to ping the 10.33 core switch from the ASA 1 from the context A. I can also ping the core switch 1. Fantastic. Now if I go to the context B, I should be able to ping 15.17, which is going this way outside B, and then I should also be able to ping the core switch to 15.1, 15.41. I can ping the core switch too. I can also ping the ISP router too. So everything is perfect as of now. With that being said, we have finished our step 2. At the same time, we have finished our step 3 as well. We have authenticated the interfaces inside the context. We have configured the interface monitoring as well, and the management interface as well. So I'll see you in my next step, which is step 4.